Let us solve a couple of problems. Given integral x to the power of m times natural log to the power of n of x dx, we will arrive at a reduction formula using integration by parts. So in this, we will take u as natural log to the power of n of x. Differentiating it, we get du is equal to n times the natural log to the power of n minus 1 x times the derivative of natural log of x, which is 1 by x and dx. Now, if you have taken u as this, then dv will be equal to x to the power of m dx. Now, to get v, we integrate both sides. We get v is equal to m to the power of x to the power of m plus 1 divided by m plus 1. Remember the integration by parts? So, integral of u is natural log to the power of nx times dv is equal to x to the power of m times dx is equal to uv. uv is natural log to the power of nx times v. v is x to the power of m plus 1 by m plus 1 minus integral of v du. v is x to the power of m plus 1 by m plus 1 times du is n times natural log to the power of n minus 1 x times 1 by x dx. Let's simplify this. First term is okay. Minus. Now, the second term, n is a constant, m plus 1 is a constant. So, we take it out of the integral. N by m plus 1 times the integral of x to the power of m, but it is m plus 1, no? So, here in the denominator, we have x. So if you bring it up, it becomes m plus 1 minus 1, which is m, times natural log to the power of n minus 1 x dx. Here, the power of natural log of x is getting reduced. Now, this can be written as minus n by m plus 1 times I sub n minus 1, this integral. So this is the general reduction formula, or integral of x to the power of m times natural log to the power of n of x dx. Now let's look at a concrete example. Integral of x cubed times natural log to the power of 4x dx. Now I sub 4 is equal to x to the power of 3 plus 1 by 3 plus 1 times natural log to the power of 4x minus 4 by 3 plus 1 times I sub 4 minus 1. This becomes 4 by 4, that is 1, times I sub 3. And here in this first term, we get x to the power of 4 by 4 times natural log to the power of 4 of x. Now we repeat this exercise. I sub 3 is equal to x to the power of 3 plus 1 by 3 plus 1 times natural log to the power of 3 of x minus 3 by 3 plus 1 times I sub 3 minus 1. Simplifying it, we get I sub 3 is equal to x to the power of 4 by 4 times natural log cube x minus 3 by 4 times I2. I2 is equal to x to the power of 3 plus 1 by 3 plus 1 times natural log square x minus 2 by 3 plus 1 times I sub 2 minus 1. Simplifying it, we get x to the power of 4 by 4 times natural log square x minus 1 by 2 times I sub 1. I sub 1 is equal to x to the power of 4 by 4 times natural log of x minus 1 by 4 times I sub 0. I sub 0 is equal to integral of x to the power of 3 times natural log to the power of 0 x dx. We have understood the pattern. Now, natural log to the power of 0x is 1. So it disappears. we are left with integral of x cube dx is equal to, we know this, x to the power of 4 by 4. Now combining all of these into I sub 4. So we have I sub 4, first term, minus I sub 3. So we build up this expression by incorporating all of these. Now opening up the brackets, we get I sub 4 is equal to x to the power of 4 by 4 times natural log to the power of 4x minus x to the power of 4 by 4 times natural log cube x plus 3x to the power of 4 by 16 times natural log square x minus 3x to the power of 4 by 32 times natural log x plus 3x to the power of 4 by 128. And we should not forget plus c. So that is the integral of x cube times natural log to the power of 4x dx using the reduction formula that we have derived. Okay, now let's look at the second problem. The second problem is j of alpha is equal to a definite integral from 0 to pi of x square times sine alpha x dx, where alpha is not equal to 0. Because if alpha is equal to 0, this becomes 0, sine 0 becomes 0. So that means this entire integral becomes 0. This is an integral between 0 and pi. So let's see how it looks like. And it depends on alpha. Without that 0 to pi limits, the function looks like this. And as I change alpha, the graph changes like this. I'm going between minus 5 to 5 for the value of alpha. Now, what are we actually looking at in this integral? We are looking at this area, this area. This point is 0, this point is pi. Between 0 and pi, we are trying to arrive at the area under the curve. So this is how it would look like as I change alpha. We need to arrive at an expression for this. So let us see how we can arrive at that. So let u is equal to x square, which implies du is equal to 2x dx, which means dv is equal to sine alpha x dx. Integrating both sides, we get v is equal to minus cos alpha x by alpha. Now we apply the integration by parts for definite integrals. So we get minus x square times cos alpha x by alpha from 0 to pi plus integral of 0 to pi 2x cos alpha x by alpha dx. So here, remember the formula is uv minus integral of v du. Okay, and for the definite part, we establish the limits here. J of alpha is equal to, now if we apply the limits, what will happen? We will have minus pi square times cos alpha pi by alpha minus 0 gets applied to x. So which means the entire term becomes 0. Then we have plus 2 by alpha. Now here remember, integral b du it is. V is minus. So that is why it's actually, as per the formula, it is minus. But because there is a minus coming out of the integral, it becomes plus. So plus 2 by alpha, because alpha is a constant, times the integral of 0 to pi of x cos alpha x dx. Now, let's take this integral, definite integral, as k of alpha. Now, again we do substitution to integrate this. So u is equal to x, which implies du is equal to dx. That means dv is equal to cos alpha x dx, which implies v is equal to sine alpha x by alpha. So k of alpha is equal to, again we apply integration by parts for definite integrals. X times sine alpha x by alpha from 0 to pi minus the integral 0 to pi of sine alpha x by alpha dx. So k of alpha is equal to x times sine alpha x by alpha from 0 to pi minus 1 by alpha. We take it out. Times the integral 0 to pi of sine alpha x dx. Now let's evaluate this integral. We get minus cos alpha x by alpha from 0 to pi. And solving that, we get 1 minus cos alpha pi by alpha. K of alpha is equal to x times sine alpha x by alpha from 0 to pi minus 1 minus cos alpha pi by alpha square. Because 1 alpha is already there here outside the integral. From inside the integral, one more alpha will come. So alpha square. So k of alpha is equal to, taking care of the limits, we get pi times sine alpha pi by alpha. But when we apply 0, the term disappears. So for the value of x equal to 0, it disappears. So we have pi times sine of alpha pi by alpha minus 1 minus cos alpha pi by alpha square. Now k alpha we substituted back into j of alpha. So we have j of alpha is equal to minus pi square times cos alpha pi by alpha plus 2 by alpha times k of alpha. 2 by alpha, where is it? Times k of alpha is pi times sine alpha pi by alpha minus 1 minus cos alpha pi by alpha square. Opening up the bracket, we get this expression. Minus pi square times cos alpha pi by alpha plus 2 pi times sine alpha pi by alpha square minus 2 minus 2 cos alpha pi by alpha cube. And combining them, we get minus alpha square pi square times cos alpha pi plus 2 alpha pi times sine alpha pi minus 2 times 1 minus cos alpha pi divided by alpha cube. Quite a mouthful, right? So the integral, the definite integral of this is this. And remember, the special thing about this is it is an integral which doesn't only depend on x, but it also depends on a parameter alpha. Interesting, right? If you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and opinions are always welcome. Thanks for watching. See you in the next session. That's it for now.